Welcome to the Maroons Academy National 5 Maths video for Pythagoras in three-dimensional shapes. We're just basically going to learn how to apply Pythagoras' theorem to three-dimensional problems. In order to do that, you need to know how to work with surds, how to solve equations, how to use Pythagoras' theorem, and the properties of common three-dimensional shapes, because they're not going to necessarily tell you them. Just a quick reminder, if you're looking for the Pythagoras theorems, the hypotenuse is always across from right angle, and to find the hypotenuse, all you need to do is use the formula a squared equals b squared plus c squared, where a squared represents our hypotenuse. And if you're looking for one of the other sides, either c or b, to find a shorter side, because the hypotenuse is the longest side of a right angle triangle, you would use a different form. Well, it's the same formula, just rearranged. And it goes a squared minus b squared equals c squared. And again, a squared will represent your hypotenuse. Okay. Now let's try this. Okay, to find the longest diagonal on the following shape, that's what we need to do. So what they're saying is they would like us to find the diagonal that goes from, I'm going to put this in green, the bottom corner here up to the far top corner there. So we're doing the diagonal A, oops, doing the line A to G. That is what we're trying to find. And the thing about that is that we don't have enough information, because the triangle that this creates is goes from A to G on the diagonal, but on the bottom it's A to C and then C to G. So the line that we need and that we don't have is actually this, I'm going to do this line in yellow just to make it a little bit easier. The one we need and we don't have is this line here. And that's going to make the base of our triangle. We know the height is 16 centimeters. That's been given to us. But we need to find that other line. Now, in order to do that, we're going to have to do another Pythagoras problem. And that is for this triangle right here. So if I were to redraw that triangle on the side, there's my right angle, I would have BCA. From B to C, we know is 12 centimeters. From A to B is 28 centimeters. And the diagonal line, the yellow line, is our A to C. So at the moment, I'm just going to call that X. And we need that before we can find A to G. So we're going to have to do two Pythagoras questions. Now, X is the hypotenuse of this. So we're going to use the formula A squared equals B squared plus C squared. Remember, if you're looking for a hypotenuse, you add. If you're looking for a shorter side, you subtract. Instead of A, we're going to have X because that's our hypotenuse. And it doesn't matter what order these go in because they're being added. So that's not an issue. So X squared is going to equal, and what I would do, what I'm encouraging my class to do, is to find 12 squared, the value of 12 squared plus 28 squared, and just get it over and done with. In this case, it's 928. And then the next step is to put it under a bracket. You could actually skip the middle step and just go to x equals square root of 928. That's fine too. But you do need to show some workings or you won't get your full credit for your work. In this case, however, when you find the square root of 928, you're left with 30.463, but I'm going to round it to 2 decimal places, so 30.46. Now, you're going to be in a test, you're going to be under a bit of stress, and you're going to feel like you've finished, but you haven't. All you've done is find the length of that yellow line, which we now know is 30.46. That is the same, that's A to C, so that's 30.46 on my drawing here. The height is still 16, and I'm going to call this Y. We're looking for AG. We have to now do a second problem. Our right angle is where the bottom of the box meets the height of the box. That's it. So we are still looking for hypotenuse. So we'll still use A squared equals B squared plus C squared. So In this case, it's going to be y squared equals 16 squared plus 30.46 squared. I'm going to write y equals, oops, the square root of 1183.81. I'm rounding to 2 decimal places again. When I take that at square root, what I get is 34.40. What is it? 34.41 if you round it to 2 decimal places. 34.41 centimeters. So while this problem looks intimidating when you first meet it, because it's a three-dimensional shape and it's a little bit, well, it's just different. Just keep in mind that on any question that asks you to find the long diagonal of a cuboid, it's going to essentially just be 2 Pythagoras questions in a row. That's all there is to it. All right, another type of question you might be asked is this, and that is finding the length of x in the pyramid, a square-based pyramid. It helps if you understand the properties of a square-based pyramid. If you draw a line from the top apex to the base of the pyramid, what you're doing is you're putting it into the center, which means, pardon me, I've got hiccups, that the distance from this line to that line is half of this distance, so it's going to be 3.5. And the distance from here to the side, is from there to there is also half, and that's going to be 6 centimeters. And that is useful for us. So let me just clear this. It's got a bit muddy. What we have to do is this. It's going to be very similar to the other problem. We need to do a two-part problem. We've got to find what the distance is. If I find my lines again, there we go. Use that green line from, say, here to there. And that will give us a triangle that looks like this. Where C is here, E is up at the top, and really the center, which we can call O, is here. We know this is 28 centimeters. This is what we're actually looking for. So what we need to find is this distance here. Now, in order to do that, we can complete the triangle at the bottom, and we can just draw a line straight to the side. Let's call that D. So what I've actually done, and I'll redraw it for you. What I've actually done is I've made a triangle from C to D to O, where D, this intersection here, right there, is our right angle. We know that the distance from D to C is half the length, that's 3.5, and we know the distance from O to D is half the length of the front line, which is 6. We talked about that a minute ago. So what we need to work on is finding that distance. And to do that, that's a hypotenuse, so we're just going to use a squared plus equals b squared plus c squared. That's going to give us a squared is equal to 6 squared plus 3.5 squared. So a squared will equal this, or I should say a, because we'll go ahead and put it under the square root bracket, is equal to the square root of 48.25. I didn't have to round, that was an exact answer. And the square root of 48.25 is 6.95. So a is equal to 6.95. So what we've done is we found the distance from O to C, which is 6.95. And we can put that into our other triangle that we drew. So that's 6.95 there. And we know that this is our square root, our square symbol, our square angle. That means 28 is at our hypotenuse. So in this case, we're going to be using the subtraction method. So we're going to have a squared take away b squared equals c squared. A squared in this case is 28, so we have 28 squared. The other side we have is 6.95, so take away 6.95 squared. And the side we're looking for is x squared. So once we've done the mathematics, x will equal the square root of 700, oops, why is that not working? The square root of 735.7. We'll round it to that. And when we take the square root of that number, what we get is 27.12 centimeters, because that is the units we've been given, equals x. Now, you can always look and see, does it look reasonable? And when you look at the triangle we've drawn, 28 is the hypotenuse, so this has to be less than 28, and it is. So it's a reasonable answer, and we're done. It's just back-to-back Pythagoras. There's really nothing more to it than that. Having said that, here is one for you to try, just the one. And you're going to have to do your own drawings. I haven't done those yet, but I will see what we can do in the answering section. If you're in my class, stop the tape, do the work, and then turn me back on when you're finished. All right, let's see how we did. Okay, in this case, you can see I've done my own little drawing already. It hasn't disappeared. The first thing we're going to do is find this little triangle here that I've got in green. We know that the base of the triangle is going to be 2 centimeters because it's halfway up, so that's 2 centimeters. And the second longest side will be 2.5 centimeters because that's halfway across. So we're looking for the hypotenuse, and we're adding. So we've got a squared is equal to 2 squared plus 2.5 squared, which means a is equal to the square root of 10.25. When you find that square root, what you get is 3.2 centimeters. There's a bit of rounding, but not a lot. Now that we've got that, what we have is the base of the triangle that's going to make us our height. That's going to help us find the height. And I've redrawn it here with the numbers put in. So I know that the diagonal, the slanted side is 6. They told me that in the problem. The base I've just found out is 3.2, and I'm looking for the vertical height on this one. Because so 6 is across from the right angle, that makes it the hypotenuse. So we're going to be subtracting. So we've got a squared minus b squared equals c squared. When we put the numbers in, what we get is 6 squared, take away 3.2 squared equals h squared, h for height. That gives us a square root of 25.76, and when we take that square root, we get 5.08 centimeters. We will do a lot more of these in class if you're in my class, and thank you for listening, and if you've got questions, let me know. All right, bye.